Alright guys, welcome to today's video. Today we're going to do some boost tuning on this Edge motor up high. So before we take off, let me tell you a little bit about why we're doing that. The boost has to be dialed in across the board on this engine, and the ECU controls the servo, which controls the wastegate. And there's a couple of reasons why they're doing it that way. It allows for maintaining boost as you go up, or in this case I'm actually going to be tapering it off, but I'm not tapering it off as fast as it would naturally if you just set the boost at a certain amount of pressure, and then as you go up you're losing atmospheric pressure. I don't want it to actually bleed off quite that fast. And the reason that I want it to taper but not taper as fast as it would naturally is because you're working around the limitations of a fixed pitch prop. And having a fixed pitch prop actually makes this far more complicated. When you have a fixed pitch prop, so I'm at 6,600 feet here, and if I have my prop set at 21.5 degrees, which is what it's set at on Whirlwind's little tool, that allows me to run about 40.5 inches of manifold pressure here, and that is a steep takeoff. I'm at 5,700 plus RPMs, okay? So that's about all I can get out of it up here. And that's fine. That's actually about where I'd like to be, because I'm just shooting for that, approximately 140 horsepower. It's, basically I'm going for 915 horsepower in a lighter package that fits under the cowling of an S7 better. And that's, I'm good with that. That's less than Edge's limits. You can run 155 horsepower, which depending on which exhaust you have, that's usually up around 46 inches. This airplane weighed 796 on 31s, and it's on 29s, so it's a fair bit under 800 pounds. Quite a bit lighter than a lot of, like, say, the Kit Foxes and stuff that you see these Edge motors in. So I don't think there's any reason to push it that hard. I mean, you guys probably saw that video a while back. Took off from 13,500 feet uphill. I wasn't even running as much manifold pressure as I actually could. So my RPM was down a little bit, and it still blasted off that short spot uphill. There's not too many places higher than that in the US that you can land. I think it's probably enough power. So yes, you're probably thinking, well, you could run more pitch and then you could run more power. Why not just do that? Well, there's a couple of reasons. Number one, as I just stated, I'd like to keep this engine alive and have a long life. Number two, I'm already pushing more power through this prop than it's rated to handle, and so until I get a bigger prop, which is on the list, I don't want to destroy this propeller. And number three, probably the most important reason, is this. If I added more pitch up here to be able to take advantage of more power, when I go to sea level, I'd be so over-pitched that even if I turned up the manifold pressure to the maximum that Edge allows you to run on the engine, I'd still be lugging it. I'd still be at too low of an RPM. And lugging a Rotax is not a good deal. You don't want to lug them in cruise, and you definitely don't want to lug them under high power. And Edge states they'd like to see 5,500 RPM minimum when you're at full power. So I have to compromise. It also means when I go up high, it would be nice to have more prop pitch, because I have to run a lot less manifold pressure up high in order to not overspeed the engine. And that's what we're going to be doing today, is taking it up high, tuning the boost, making sure it's set right to where I can get as much power as I can get up there, but not overspeed the engine. My guess is at 18,000 feet, probably only going to be able to run like 34 inches or around there. The cool thing about this system is I've got the dual cowl ECU, which means I have a switch on the panel, and I can flip that and have two different maps, and I can tune those maps differently. Tune the boost, tune the air-fuel ratios, tune everything. And what's awesome about that is map number 2 is my takeoff and performance map. The boost comes on quick and aggressively. It makes, full boost, high power. That's an awesome map for climbing, but it's not a good map for cruising. Map number 1 is my lazy lower boost map, and the reason is when you back off the wastegate, let it open sooner, it makes it more efficient when you're cruising under lower power levels. Not low, but what would be a moderate power level. When you bring the wastegate in too early and too high and you're trying to command too much boost, you end up having to pull the throttle handle way back, and now you've got the throttle plate closed way off, and the poor turbo is working really hard to push enough air around that closed off throttle plate. That's a small hole essentially, in order to feed the engine with the required power to cruise. So the turbo ends up working really hard, but you're not really getting anything out of it. If you back the wastegate off, let it open earlier, it allows you to move the throttle handle further up. You know, you're advancing the throttle further forward, but you're not actually getting any more manifold pressure than what you want for cruising. But the turbo isn't working nearly as hard to do that. And I proved that. I've proved it in the air in real time, and it's amazing the difference it makes. I'll end up with the same manifold pressure, but quite a bit higher RPM at the same altitude, same variables, you know, because you're not driving that turbo so hard. You're letting more exhaust go around the turbo instead of the engine having to pump it through the turbo, and the turbo's working hard, but in the end you're only getting the same amount of manifold pressure. So hopefully that makes sense. It's a little hard to explain, but it's a real thing. Okay, anyway, enough talking about it. Let's take it upstairs and see what we got. As you can see there, I just flipped over to my low boost map and it brought it down to like 32 inches, which is actually a little lower than I'd like. So I need to work on that a little bit. But it's pretty cool. I didn't have to move the throttle at all. Just flip the switch, goes into like lower boost extended climb mode. Normally I don't climb as long as I just did under full power. Usually I climb about half that long, but I wanted to take a little video clip and kind of just watch that climb rate, and it really doesn't change much. The boost was dropping a little bit as we climb, which it's supposed to do. You know, we're already at 9,000 feet, and we just left, I mean, what, a minute ago or something? That's crazy. So now we'll do a kind of an extended climb up to high altitude with this lower boost map, and I may get out the laptop and actually raise the boost a little bit. Because it's okay to run a little more than this. All right, so the way this system works, you probably couldn't really tell from the video and really see what's going on the laptop, but essentially you've got duty cycles for the servo, and the servo controls the wastegate via a cable. So basically you're roughing out those duty cycle values to get the wastegate approximately where you need it to make the boost you want. There is a dynamic sort of like function of the boost control in the ECU where it will vary things a certain amount to meet the target. And what you might have noticed in the video is there was times where it was kind of surging. The RPM was going up and down a little bit. The boost was hunting a little bit. I've noticed with this system that it is a little bit tricky to get it perfectly steady, but it was worse in the video than it normally is, or that it can be, for two reasons. Number one, I had made some changes to the wastegate adjustment, and I kind of had just roughed in those numbers. I didn't have them as smooth from different, like, basically they're like load values, I guess is the way you could look at it, and I didn't have them smoothed out all the way yet. That's part of it. The other part of it is on the dynamic boost control, there is an adjustment for how aggressive it is swaying the boost to try to meet your boost target, and I had it turned up to be pretty aggressive. Reason being, if I had something way off and it tried to overshoot the boost real bad, that thing will jump in and catch it quicker before it gets away from you. The flip side is it hunts more. It sees a little bit of difference and it goes in and makes an adjustment, and then it's too far, and then it makes an adjustment, and then it's too far, and it's going back and forth and hunting. So since I got back down, I turned that compensation, or that part of it, I turned it back down a little bit to where it's not so aggressive. All right, well, I'm really glad I did this. Obviously, I wanted to go up there and get those values set just in case I'm up in the mountains and got to climb up over, the mountains to get away from the wind on a windy day or something like that. I'd like to have everything kind of set up right. But it was interesting. I wasn't able to run quite as much boost as I thought. Up at 18,000 feet, it's down to like 31.5 inches and right at the red line. So, I thought I was going to be able to run a little bit more. Anyway, interesting stuff. Now you guys are probably thinking, hey, just put a variable pitch prop on it and be done with all this. You can get tons more power, you can go way up high, down low, it doesn't matter. True, yes, but there's some negatives that go with that I think kind of offset it. Of course, the obvious cost, blade selection or lack thereof, maintenance, things like that, but you've also got, the biggest one for me is nose weight. The S7 is already, it doesn't like a lot of nose weight, and being a turbo motor, it's heavy enough on the nose. So adding more is not really a great deal. I've already got a little header tank in the back. That kind of offsets it. And I still need, 10 to 15 pounds of baggage, survival gear, tools, things like that, things you should have with you. But that is kind of what it takes in the baggage area to keep it being able to 3-point. And without that weight, you can't reliably 3-point it, and you can't brake as hard. So I think I'm going to stick with the fixed pitch and just obviously have to work around it with these. But you look at it and you go, I was able to take off on that spot on the side of that hill up really high. I mean, and then you go beyond that and it's just, how much power do you really need? You guys saw the videos climbing through 16,000 feet, holding above 1,000 foot a minute, no problem. And fairly heavy. I mean, that's phenomenal performance. So I'm being realistic and going, I'm not doing a stole contest at 18,000 feet. So having still above sea level power is awesome. Climbs great and do anything you need to do. So that's kind of my thoughts on it. Let me know what you guys think. All right, guys, I thought I'd just bring up one more quick thing and see if there was any interest. I was thinking about putting together a video basically focused on, off-airport landings, off-airport flying in general, the decision-making process of finding a good spot to land, density, altitude concerns beyond the obvious like power, some of the experiences I've had, some of the things I've learned, some of the things I've done right and wrong, and various airplane type, nose wheel versus tail dragger, because I've done quite a bit of that in both, and just kind of go over some of what I've learned about it. There's a lot of good resources out there, of course, if you search around, but
I just thought, you know, I've done it for enough years, I could probably add a little something into that discussion. And of course, it's something that I'm super into, and obviously my main focus when I'm out flying is looking for cool new places to land. So let me know if you think that'd be worth doing as an upcoming sort of winter project. But anyway, let me know what you guys think. And also, Patreons, thank you very much. Appreciate you guys supporting the channel, keeping me going. If you guys would like to be a part of that, it is very much appreciated and helps out a lot. And I'll put a link up here so you can join that. So thank you very much. All right, guys, you know the deal. We will see you on the next one. Take care.